So space is actually full of dust. I'm talking about billowing pillars of dust extending over 1 billion kilometers in size. But with all this cosmic dust floating around, how exactly do orbiting observatories like the James Webb Space Telescope actually see through it? Alright, first let's go over the basics of what cosmic dust actually is. In contrast to your typical household dust bunnies, cosmic dust is a collection of extremely tiny solid matter particles drifting around in space. And I mean really small, like just a few molecules across. You may be wondering, how much dust is there in the universe and where did it even come from? So here's the thing. Astronomers don't exactly know the answer to these questions, but they do know that around 4,700 metric tons of dust falls onto the Earth every year. And they know that supernovas played a huge part in its production and distribution. When sun-like stars collapse and explode as a supernova, the combined garble of elements contained in their dense cores are expelled into the universe. These elements include helium, carbon, oxygen, and even iron in bigger stars. Together, they form molecular clouds with heavier elements like iron and silicon combining with oxygen to form minerals. Those tiny mineral grains are what we refer to as ding 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 dust. And this dust will never disappear because it's an essential key to the planet and star formation. Once dust is expelled from a star, it can travel to another part of the universe, create another star, and at the end of that star's life, get expelled again. And so the cycle of dust distribution continues. Unfortunately, this recycled cosmic dust is often in the way for astronomers making their observations. Because, you see, cosmic dust particles are similar in size to shorter wavelengths of light, like blue light. They have the ability to absorb or scatter those wavelengths, whereas longer wavelengths of light, like red light, pass directly through dust clouds, an effect known as interstellar reddening. All the light that gets absorbed or scattered by the dust clouds makes stars tucked behind them seem more red and faint. This means that the average human eye looking through a regular old telescope is no match for a dust cloud, since most of the light reaching that telescope will be outside the visible light spectrum. For many years, this limited what astronomers could observe until William Herschel discovered infrared light in 1800, opening a world of possibilities. Modern observatories are utilizing the longer infrared wavelengths to see beyond the naked eye and through dust. Observatories have even found water and other organic molecules on asteroids. But now astronomers want to see in even greater detail. And this is where the James Webb Space Telescope comes into play. Webb can observe even longer infrared wavelengths, and paired with its advanced detectors, this observatory can analyze a much wider range of light than observatories before it. But Webb will be doing more than just looking through the dust. It might be able to help solve one major dust-related problem called the dust budget crisis. This is the inability to account for all the dust found throughout the universe. Webb will be working with JWST to observe infrared light from wolf-rayet stars that help count it. Wolf-rayet stars are supermassive stars at a very late stage of stellar life. When observed in infrared light, they've been seen releasing dust in a pinwheel pattern, like this one named WR112, which astronomers call a highly efficient dust factory. It's capable of producing the Earth's massive dust in just 1 year. Once Webb takes to the skies, it'll be able to observe the chemical signatures produced from wolf-rayet stars that could provide us with a better understanding of not only early planet formation, but also how the universe got so dusty. All of this to say, astronomers have come a long way in their quest to probe the dusty closet that is our universe. And the hope is that James Webb will help clear the skies for many more years of space discovery. If you love space as much as I do, be sure to subscribe to Seeker for all your latest updates and check out this video here. Thanks so much for watching, and I'll see you next time.